Welcome to one of Europe's largest construction projects, Britain's $57 billion nuclear experiment. A marvel of engineering or a colossal disaster in the making. Let's dive into the controversies, challenges, and triumphs of Hinkley Point C. In the mid-20th century, the United Kingdom stood at the forefront of atomic innovation. In 1956, at the Calder Hall Power Station in northern England, history was made. It wasn't just the UK's first commercial nuclear power station, it was the world's first. The nation harnessed the atom to generate electricity, a revolutionary step that inspired others to follow. But the UK pioneering momentum didn't last. By the 1980s, the construction of new nuclear facilities slowed, and over time, many of the early reactors reached the end of their lifespans. While the world advanced, Britain's nuclear progress stalled. Today, only 9 nuclear reactors remain operational across the UK, providing roughly 13% of the country's electricity. With 6 reactors already shut down in recent years, the country faces a stark reality: without action, its nuclear capability will fade away entirely. But Britain isn't giving up. Far from it. By 2050, the UK has set its sights on an ambitious target, quadrupling its nuclear capacity. This means building as many as 8 new reactors, transforming nuclear into a cornerstone of the nation's energy strategy once again. Hinkley Point C, one of Europe's largest construction projects, is a key part of this plan. With 2 reactors capable of powering 6 million homes for the next 60 years, it represents 1/4 of the UK's nuclear energy goals. This ambitious program is about more than energy, it's about securing the future. In a world increasingly focused on reducing carbon emissions, nuclear power offers a reliable, low-carbon solution to meet growing demand. The question is, can Britain reignite its role as a global nuclear leader, or will it be overshadowed by delays and controversies? The stakes couldn't be higher, and the race to 2050 has only just begun. Hinkley Point C, spanning an enormous 430 acres along the south bank of the Bristol Channel, this site dwarfs its neighbours Hinkley Points A and, both relics of the UK's earlier nuclear ambitions. When complete, Hinkley Point C will be a game-changer. Its 2 cutting-edge reactors will provide enough electricity to power 6 million homes for the next 60 years, roughly 7% of the UK's total energy demand. This is a critical step in securing the country's energy future. To bring this megaproject to life, a feat of engineering muscle was required. Meet Big Carl, the world's largest land-based crane, towering 250 meters high and capable of lifting up to 5,000 tons. It's been instrumental in positioning colossal components like the reactor domes and steel liner rings. Every aspect of this project is a spectacle of scale and precision. Over 9,000 cubic meters of concrete were poured in a single operation, breaking records held by iconic structures like the Shard in London. British regulations also demanded 35% more steel than similar reactors in France and Finland, adding to the complexity. But size isn't the only thing that sets Hinkley Point C apart. At its heart lies the European Pressurized Reactor, or EPR. This next-generation design uses 17% less uranium than traditional reactors, while incorporating 4 advanced safety systems to protect against hazards like floods and earthquakes. EPR have already been deployed in France and Finland, but Hinkley Point C is the first mega-project to bring this technology to the UK. This untested design on British soil has added a layer of complexity, requiring over 7,000 regulatory adjustments to meet the country's strict safety standards. Hinkley Point C isn't just another power plant, it's a statement, a bold declaration that the UK is willing to take on the challenges of building the future of energy, one massive steel component at a time. At its inception, Hinkley Point C was hailed as a beacon of progress, a £18 billion investment in the UK energy future. But fast forward to today, and that number has ballooned to an eye-watering £46 billion. Before we continue, please subscribe our channel. The reasons are many. Regulatory changes added complexity, requiring over 7,000 design adjustments to meet British safety standards. Labor shortages and supply chain disruptions, exacerbated by the pandemic, caused delays and drove up costs. And then inflation pushed the final price tag to unprecedented heights. Originally scheduled for completion in 2025, Hinkley Point C now aims to have one reactor operational by 2029, with full power unlikely before 2031. Years of setbacks have turned what should have been a triumph into a test of endurance. Beyond financial struggles, environmental concerns have added another layer of controversy. To keep its reactors cool, Hinkley Point C will draw a staggering 120,000 liters of water per second from the Bristol Channel. But this process risks devastating marine ecosystems, potentially pulling thousands of fish into the system every month. In response, EDF proposed a fish recovery and return system, designed to minimize harm by safely redirecting marine life. But critics argue this isn't enough to address the scale of the problem. The Marine Management Organization recommended adding an acoustic deterrent, a sound system to scare fish away from the intakes. EDF opposed this, calling it dangerous to install and unproven in its effectiveness. Instead, they suggested creating new salt marshes as alternative breeding grounds for wildlife. But even this alternative sparked outrage. Hundreds of acres of farmland would need to be flooded to build the marshes, prompting fierce resistance from local farmers and councils. Many argue this solution sacrifices land-based ecosystems for marine ones. With soaring costs, extended delays, and environmental debates raging on, Hinkley Point C stands at the crossroads of innovation and controversy. Can it deliver on its promise of clean energy, or will the mounting challenges overshadow its potential? Amid the delays, cost overruns, and controversies, one fact remains undeniable: Hinkley Point C is a true engineering marvel. A project of this scale and complexity hasn't been attempted in the UK for over 30 years, making its achievements all the more remarkable. At the heart of this project lies a commitment to safety. The European pressurized reactors here are designed with 4 layers of protection against floods, earthquakes, and other potential hazards. These measures ensure that Hinkley Point C can withstand challenges far beyond those expected in the UK. And the engineering ingenuity doesn't stop there. While building Unit 1 was a monumental challenge, the lessons learned have transformed the construction process for Unit 2. By refining techniques, workers are now assembling key components up to 30% faster, shaving months off the timeline. The answer lies in the ticking clock of energy security. Many of the UK's existing nuclear reactors, once the backbone of the nation's power grid, are nearing the end of their operational lifespans. Without replacements, the country risks losing a critical source of reliable, low-carbon energy. Enter Hinkley Point C and its future counterpart, Sizewell C. These megaprojects are more than just power plants, they're blueprints for the UK nuclear renaissance. The lessons learned from the challenges at Hinkley Point are shaping the approach to Sizewell C, with the goal of avoiding delays, reducing costs, and improving efficiency. But there's a bigger picture at play. In a world grappling with the climate crisis, nuclear power offers a lifeline, providing clean, consistent energy to complement intermittent renewables like wind and solar. It's a crucial piece of the puzzle in achieving net zero emissions. By 2050, the UK plans to quadruple its nuclear capacity. The stakes couldn't be higher. If successful, this strategy could position Britain as a global leader in clean energy innovation. But the question remains, can the lessons of Hinkley Point C pave the way for a smoother path forward, or will history repeat itself? Let us know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell for more deep dives into the mega project stories shaping our world.